Hi everyone, this is Mr. West. We are doing a challenge today in Khan Academy, the Evaluate Radical Expressions Challenge. So this should be a little bit more difficult than normal, but hopefully you'll learn something from this process. We'll go ahead and start. It says evaluate, and it has the fifth root of negative 16 times the fifth root of 2. We're asked to essentially simplify this. We need this to get an integer, maybe a number with only one power or radical. And now I'm gonna actually I'm gonna teach you the kind of the longer way to do this problem, and that will be useful when you have more complicated ones. But if you want to see the short version, go ahead and fast forward. The bottom line is, for the short version, you're going to multiply these two underneath the same radical and then simplify from there. But I'm going to show you that often when you have problems like this, you see that you have a negative 16 and a positive 2. So you can break this down into its more basic components. For example, for negative 16, I would put it as negative 1 fifth root times 16 fifth root times 2 fifth root. Okay? And then when you have this, I like to change it to radical exponents, but we know the fifth root of negative 1, that is just going to be negative 1. Anytime it's an odd number root with a negative, it's going to stay negative once you're done evaluating it. Now with the 16, you can change this. Well, what you want to do is normally you'll want to change this so that it has a like base. So what we can do here is you can change this 16 to have a 2 for a base, because this one's already into its most basic prime number, 2. So we're going to change this to 2 to the 4th power. That is the same thing as 16. Don't forget that I have that fifth root there still, okay? So now it's rewritten like this. Okay, from here, this negative 1 just becomes a negative. So I'm going to apply that negative at the end. Just drop my pencil. Back in the game. Okay, now anytime we have roots, we can rewrite them as a fraction exponent. So I can change this to 2 to the 4/5 power, and I can change this to the 1/5 power. You'll see now, and I'm not sure if this is the way it intended us to solve this, but now we have a common base. We're multiplying exponents, so we're going to add, or multiplying like bases, so we're going to add the exponents together. So we are going to add 4/5 and 1/5. Well, we know 4/5 and 1/5 is just 5/5 or 1. We know that negative stays out in front, and we know our base is 2. So we have negative 2 to the 5/5. That's equal to negative 2 to the 1st power. Exponents first. 2 to the 1st is 2. Negative 2 is going to be our answer. Okay. Now, I'm going to show you the quick way. And hopefully, if you wanted to, you already fast forward at this point. But the quick way, as I said earlier, is because it has the same root, you can combine the negative 16 times the 2 inside the radical together, okay? Because they have the same number, 5 and 5 there. That's why you can do that. So then you have the fifth root of negative 32, and you can either use your calculator or just think to yourself, what times itself 5 times gives you negative 32, and that's negative 2. Okay, so that's the quick way, probably what it wants you to do. But I just wanted to show you that other way to do it. I'm glad I showed you the other way, because now it gives you rational. I knew it was going to do this. Okay, so we have 125 to the negative 11/12 divided by 125 over the negative 1/4. The first thing I'm actually going to do is get rid of these negative exponents. Anytime you have a negative exponent, it just simply means, to make it positive, you just have to move it to the denominator if it's in the numerator, or to the numerator if it's already in the denominator. So we're going to have 125 to the 1/4 power divided by 125 to the 11/12 power. Okay, we have like bases here, 125, so this is actually pretty good because we have this divide here, this divide symbol, and that, or that fraction, that just means divide. So we're going to have divide. And anytime we have divide with like bases, it means we are going to subtract exponents. 11/12. What does this become? Well, we're going to have 125, and then we have 1/4 minus 11/12. That's one of our exponent rules. So now we just need to simplify 1/4 minus 11 over 12. That's probably the easiest thing to do. And we're going to multiply it by 3 over 3 to have a common denominator of 12. So we have 3 over 12 minus 11 over 12. And we are going to get negative 8 over 12. Okay? So step 1, negative exponents. Here, change to positive exponents. Boom, done. Then change the fraction to division. Use our power rules, which are subtraction when you use division of like basis. So now we have 125 to the negative 8 over 12 power. We should simplify this even further. Okay, so that's, what is that? Divide both by 4, and you get negative 2 over 3. 125 to the negative 2 over 3. All right, almost done. So we need to, if it's a negative exponent, we need to rewrite it to be positive. So we have 1 over 125 to the 2 over 3 powers. I made it positive by putting it into the denominator. Now, I think the easiest thing to do from here is think of this in terms of, I should use a different color, in terms of a radical. Anytime you have a number in the bottom here, it's the root. So this really becomes the third root, the cubed root of 125. And then we could either square it inside here or square it afterwards. It doesn't matter. It's the same thing. Okay, but the bottom line is we need to square it because that's what that 2 is. I'm going to make that green. Okay, we got to square it because that's what that 2 is. And we have to take the cube root of it because that 3 on the bottom of the exponent fraction, it means the root. Now, the reason why I usually like taking the root first, especially when it's a big number like that, because you want to make it smaller before you make it bigger. Technically, you could do 125 squared and then take the cube root of it, but it's going to be a lot easier to take the cube root first because you want a smaller number before we make it too big. So we get 1 over the cube root of 125. What times itself 3 times equals 5? 5. And then we still have to square this. So when we square it, we get 1 over 25, and that's our final answer. So pretty interesting. I didn't even mean to do this, but right next to it, the original, that this monstrosity becomes 1 over 25. So that we're going to type that in, 1 over 25. Okay. Whew, boy, it's really testing us here. Okay, so we have 3 to the 1/5, and then we have divided by negative 96, the 5th root of that. We have division. We don't have negative exponents, so we're actually off to a decent start here. I'm going to write 3. Let's go blue. 3 to the 1/5 divided by, and then now we have negative 96, and I'm going to write this as an exponent to the 1/5 power. Now, we don't have like bases. This is a problem. We need to make sure that these numbers are the same. Obviously, because the 3 can't be broken down anymore, we're going to try to get this negative 96 to have a base of 3. So we're going to have to do some finagling here. Not sure what we're going to do quite yet. I think I'm going to take this negative 96 and play around with it and break it down into its prime factors just so I can see what's going on. First, I'm going to take out the negative 1. Okay, I don't want to deal with that negative 1. He's going to go bye-bye, okay? So we're going to kind of set him off to the side. Now I'm going to break down this 96. I think that's 48 and 2. I like to put the prime on the left. Okay, so 48 and... Oops. 48 and 2. Okay, and then I can break that down. Let's see, double check. Okay, that's correct. And then I can break that down into 2 again. That's 24. I can break that down into 2 again. And then that's 12, and I can break that down into 2 again. And that's 6, and I can break that down into 2 again. And that's 3. Okay, so this one's not like the other one where we can get this base into the same in the same way. What this one actually is testing us is if we can simplify a radical. When we have a radical like square root of 96, we're looking, or sorry, it's not square root, it's the 5th root of 96. We're looking for a number that appears 5 times. Okay, here we have 5 2's. Technically, we could rewrite this as 2 times 2 times 2 times 2 times 2. And then times, what was left by itself? This guy. times fifth root of 3. That's another way we can multiply this together. What does that become? It becomes the fifth root of 32 times the fifth root of 3. 32 times 3, 96. Okay, why did I write it like that? Because we know the fifth root of 32. We know something times itself 5 times equals 32, and that's 2. So this number is the same thing as the 2 times the fifth root of 3. So let me go back to this right here. I'm going to erase this. We know that instead we can say it's divided by a negative 2 fifth root of 3. Fifth root of 3. So I'm going to write it as this originally. Okay. Now, this written like this actually doesn't do us any good. Sometimes you have to have like a plan in place and then realize, hey, my plan wasn't the right plan. I should just go back to the original plan, which is I'm going to convert this back into a radical. I've been playing with radicals mostly. I'm going to keep this negative 2 in the bottom back into the fraction. So we have negative 2. And then I have this fifth root of 3 in the bottom too. Well, guess what? I can cancel that in the top and bottom, and I'm left with 1 over negative 2, or negative 1/2. I like to put the negative in the top personally, negative 1 over 2. Okay, so we can recognize here that we can cancel once we break it down into its smaller components, and this is more of a simplify radicals problem versus the exponents problem. Definitely a challenge. I mean, this is aptly named radical expressions challenge. So this is pretty good. Okay, last one here, and then we're done. Notice how we have third root on top, third root on the bottom. I'm guessing it wants us to simplify this radical just like we did in the last one. This isn't like a rewrite one. So we're going to go ahead and simplify this, break it down, and I'm going to do, what do you call it? What are those things called? Prime numbers on the left. So then I have 5, and then was it 5 times 25, right? Yeah. Then we have 25, and then I'll break this down, and we get 5 times 5. Okay, and this is, oh, sorry, I always forget the root. There. Now, because it's the third root, we're looking for any number we see 3 times, okay? And I could have really stopped here because I realized 125 is a perfect cube. So, but basically, my students like showing that if you have a cubed root and you have 3 of a number, one of those numbers is going to come out. Let me show you in just a second. And then I'm actually going to keep I don't know why I'm doing this, but there, that's why. Cube root of 2. So anytime that we have the cube root of 125, what times itself 3 times? That's 5, because that's what this demonstrates. So we have 5, and then cube root of 2. So this top number becomes 5 cube root of 2, and then this is over cube root of 2. The cube roots cancel, and you're left with just 5 over 1, or 5. So our answer is 5 here. And that's it. So that is the challenge, and we've just come. It always cuts me off as I'm trying to be epic with the outro. But anyway, hope you enjoyed this video. If you want me to do more challenges, let me know. If you need help with anything else related to math, high school math, anything you need, leave a comment, tell me what you need, and I'm here for you. And I look forward to seeing you next time right here on West Explains Best.